I'm preparing the setup for the sweeps, and the first thing I need to do is make sure that the spindle is lined up with the rotary table for the center. I've just completed that. I'm just touching off on the inside of the hole here, X and Y. That's all complete. So the jig here, I've got these two blocks here are reference blocks for positioning, and underneath there's support to keep it up off the table. It's 1 inch up, and I've got the clamps here that will actually clamp it down. There's some more blocks under there for it to tighten up against. So the idea is that this butts up against here and up against here, and that gives me my reference. These are held down with separate clamps. I'm going to start cutting the sweeps on this side, but then I have to do the other side. And by using the reference blocks, I can loosen these up and put them on this side to cut the other edge of this, the outer part of it, and not lose my index to go in. So these are indexing blocks. But it's not calibrated yet. I have to go over my charts and get the positions. I'm going to be doing an X and Y up here and an X over here, and that should get everything positioned the way that I need to, as long as I get my numbers right. Almost there. I'm probably going to have a couple iterations because of working with a couple different axes here and different clamps, because when I move this, it's probably going to change the angle here. I think I got my layout set up here. I didn't record it because it was just way too much fiddling to get everything lined up between here and the stops. I'm not even going to go into all the detail of it, but yeah, it was a pain to set up, but I knew it was going to be. But basically it butts up against here, and I slide in a 1, 2, 3 block on this part, which you can't see it, but there's a shoulder under there and it stops on that, this piece coming back against it. I'm using this 1, 2, 3 block here as a reference when I slide that in. Let me grab it, I'll show that. So this would be the one that I would use as a guide. Yeah, okay, it's a little tight now because I got that clamped right down. But I push it up tight against this one, which that clamp stays tight all the time. I slide that in until I come up in here, and there's a shoulder like that. So this pushes down onto that 1, 2, 3 block, and we've got a reference for the depth on X, and Y is done by butting up against that side of this 1, 2, 3 block. So that references that, and the other part is the tip over here, so the swing is right going in and out from the corner here. And that would be a 1, 2, 3 block. Let's see, it'd be this upper 1, 2, 3 block. This tab here just sits on top of it, and as long as it's tight on there, then everything is referenced there. Then I know it's positioned right. These two clamps hold the part steady while I cut, and this one holds that other reference block. Okay, so I've got the end mill is just a little bit above the part, and I'm going to turn the turntable, and we're just going to do a sweep for a sanity check. This is supposed to be 1/2 inch from this tab here up to where it starts cutting. That's where the indicator is going to go in. And by the time we get up here, we should be just exiting right about where that angle is, right up there. So I'm not going to cut this all at once because it's more than the depth of the end mill. I'm going to bring the table out a little bit and skim this first part, and we'll work our way down to the final measurement. And we're going to climb cut through this. get cleared away here so you can see. Okay, I'm going to clear out again and then we'll go for the last pass. I didn't have enough clearance there. Yep. Crap. I gotta move some stuff here. So I thought I had it back far enough, but that 1, 2, 3 block under there that was supporting this was out a little bit too far. It went into the path of the last cut. I probably took a little bit of a corner on it. Okay, I'm going to clean this, go back and do a spring pass. So when I did the setup, I thought this sweep was going to end up a little bit short, like have a little bit of that angle that was here show at the top, but it actually came out just about perfect. There's only about 0.5 millimeter there. It's basically ended up being a chamfer, which I would have put in there anyway, so much better than what it looked like at first. I think it was just trying to eyeball it with the end mill. It just couldn't see it as well as it actually was, but by the measurements, it's there. That's what I had planned. So I think what I'm going to do next, there's a deep chamfer that goes on the side here. Before I go and switch things around, I might as well get that right now. I'm not going to use the DRO position to do this. What I'm going to do, because the cutter cuts the least at the tip of it, and cuts strongest at the top, just because you have more surface feet per minute up there. So I'm going to set the edge of this, the top edge of this, so it's almost at the top of the flange, but not up into the straight section here. Just a little bit shy of the top. And then I'm going to touch off at that, and I'm going to zero the DRO. I'll lower the table 2 millimeters, which is what the chamfer is, and we're going to position X on the table till we touch off again at that lowered point. And then from there we should be able to cut this by bringing the table back up to the 2 millimeter. So that way I come back to where I started on here, and we'll cut out that 2 millimeter chamfer. And that should be close enough to the height. That's about 1 millimeter, maybe 1.5 from the top. I'm going to run this at the highest speed, 1530 RPM. Because, as I mentioned, the bottom of that, it's a small radius, so I need all the speed I can get down there. Just touching a little there. So that is touching there. I'm going to go back up to my zero. Okay, and we should be ready to cut this. So I think that'll show on the camera. We got the chamfer here. So I gotta reposition my clamps here, and we're ready to cut the groove. So to get my endpoints for the sweep that's gonna do this groove, this one's pretty straightforward. It's this line carried straight up, which is also the edge of this. So I just took a straight line from there to there and marked that out using the layout fluid so I can get a nice sharp line. This one here was a little trickier. The setback from here was 1/4 inch, 6.35 millimeter. But that's not the easiest to get that measurement because it's inset down here. But the diameter from here to that edge there, around this, is 40 millimeter. So what I did is I took this 1, 2, 3 block, set it up against the outside edge. I set this for 46.35, the 40 millimeter diameter plus the 6.35 millimeter for that 1/4 inch. And it may have moved a little bit now, but I just took this, yeah, it did move. Took that and just scribed that line that way when this was accurately set. I set this using the vernier calipers. So this should be all set, and I've got some visual marks, and I'm just going to bring that sweep out till I touch the outer edge touches those lines. And that'll do it. It's a decorative thing, so it doesn't have to be that precise anyways, but I'd like to get it as close as I can. So I wasn't sure if I could do this, but I think I've got these clamps out of the way enough that I can keep both of them on and be able to do one continuous sweep without having to break it. That'll give a better finish because I won't end up with a step in the middle. So right now, I'm just working down to my depth, and then I'll start doing the swing. I gotta clean this a little better so I can see that line. So I'm going to put the Dicom on here to see where I was touching down with the end mill. Some of it's smeared into my line, so it's making it really hard to see. It is still there, I can see it, but just a little difficult with all the chips. Almost there. It looks like it just touched, so now I can go the other way. except for a little deburring. I think that does our groove. So next I'll have to reposition these clamps to the other side, and we'll do the sweep on the other face here. Need to clear some chips here. I'm almost at the end. So the very last bit I can't get with the end mill because of the radius. I'll cut into this part. If I do, I'll have to hit that with a file to finish that up. It's the only way I can think of to actually finish that. What I probably will do though is I'll get as close as I can with this end mill, and I may come in with a smaller end mill, match it to this surface, and just get closer so I don't have to file quite as much. So that should do it. Well, the radius in there isn't as bad as I was expecting. I may just go with that and I'll hit that with a file. It's really just a tiny bit in there. So the next step is the chamfer down here. Okay, so I've changed over to the chamfer again and just about ready to cut this. A little bit of positioning. But I need to remove this clamp. This is the one that holds the reference block here. I don't need it because this is the last op on this side, and everything is held down by these two clamps. So this is going to come out, and the reason being, the sweep I can reach, but there's also the straight section down here that goes all the way out to the end. So I'll bring this back to the table. I'm at 180, which would be when I'm parallel with this, and then I'll do a y-axis move in towards the back of the machine, and that'll chamfer that straight section. So now I'm going to go in for Y. So that completes all our operations for this side. Okay, so that completes the chamfer and the groove. Now we're going to switch the clamp so I can hit the chamfer on the back. And the only thing left on this is going to be the clamp holes up here and threading. After that, I need to make the stud for up here and we'll be complete. So I'm going to have to run this one a little bit more shallow than I did on the others because I don't have enough clearance under the cap for this clamp if I go any further down, bringing the edge up closer to the wide part of this. Okay, so now I use the Y-axis and move in to finish this last bit here. So I'm preparing to do the drill and tap for the clamp screw. First step I need to do here is center. So I'm using the mini mill here because I'm going to be doing the tap, just power tap it, and this is set up for the power tapping. Looks good. Okay, so next, the drawings call for drilling 5mm inboard of this line right here, that corner. It doesn't have to be like down to a couple of thousandths, it just needs to be in the ballpark. So I'm going to pull this out, and I'm just going to run the bit down and get over the edge of it, and then move over the 5mm. And that'll be close enough for that. So that's our 3mm for doing the tapped hole, which will be on the bottom part. Next I'm going to do a 4mm hole that'll be where the bolt passes through the upper one. So this is our counter bore for the head of the cap head screw that's going to go in there. It's 8mm, and we're going to drop down with 4mm. So I'm going to zero out on my Z. Now we go down 4mm. Let's get a little juice on here. should have enough length here. I can go right through the top hole and tap into the bottom. That means I don't have to flip it and realign. So with this mini mill, I have a special tapping feature in here that turns this really slow, and it is a momentary button on it. So I just put a little bit of down pressure on it lightly with the quill and use the momentary button. And I also have a reverse to back it up and clear chips. Enough torque. It's going a lot tighter than I expected. Okay, so that should be all threaded now, and we can put our bolt in it. Okay, so this part is basically completed except for a little bit of cleanup. So that's our bolt that goes in. Like that. I had a little trouble getting the tap all the way through on the bottom, and looking at my charts here, I see probably why it gave me a little trouble. I was using a 3mm drill for it's a 4mm bolt. Now I've always done this with hand tapping, just drilled it with 3mm, but according to the chart here, let's see, where are we? 4mm, M4. It's actually supposed to be a 3.3mm drill, so I'm a little bit undersized, which makes it a little tighter. You're having to squeeze through a little bit, so that explains why it was trying to stall out going through there. I dropped my belts to a lower ratio, and then I was able to get through it, but it surprised me a bit that it didn't go through on the high, because it's just a little tiny 4mm tap. Anyways, let's get the gauge out and see how that fits in there. Okay, so that's in there. So now we just got to do the stud. So in episode 3, you've seen me complete the rest of the main body of this and the assembly of the dial. I wanted to include doing the stud. This is where it mounts into the mill in episode 3, but it was just simply, there was too much video work in there, and I ran out of time to fit it within the 1 hour that I usually do, and I felt it was unreasonable to do an 1.5-hour long video to include that. So I'm going to do this in a 4th episode. I really didn't want to do a 4th on it, but to finish this up I'm going to have to. But it's only 1/2 hour video on doing this stud, So I think what I'll do is, before I put that one out, I'm going to tram the mill with this. We'll put it into use. I'll get some video of that, and I'll include that in episode 4, so you actually get to see this in use. In the meantime, hope you enjoyed what I put out today, and thanks for watching. If you've made it this far, I hope you've enjoyed watching this video and found it entertaining or educational. If so, please consider hitting like or subscribe. It does help give me incentive to continue producing more. Thank you.